Hello and welcome to the fundamentals of Solidity. In this video, you will learn the basic data types. These include Booleans, unsigned integers, strings, and bytes. These are known as primitive or non-reference types and are the building blocks of Solidity. If you enjoyed my content, please like, comment, and subscribe to help support the channel. Without further ado, let's begin. First part of this course will focus on basic data types used in Solidity. Now, to the left, you'll see a task, which is what we'll be tackling each time. And sometimes we'll see this details tab here, which will give more details as to why this section is significant. To the right, you'll see the IDE or Integrated Development Environment. It's an interface for us to type our code into, which will be compiled into bytecode using the Solidity compiler of version 0.8.2. Now, you do not need to worry about any of this as it's pre-configured for you. And you may also notice this license identifier here. Do not worry about this, it is just a Solidity standard that we use to show that this is an open source contract. Next to this, you'll notice another tab called contract.t.sol. This is the test file that gets executed for each practice question. So whenever you click test output here, run tests, it's going to run your code in here against the test file here. And as you can see, it's failed, so we don't pass this first one just yet. This is using something called Forge Standard Testing Library, which is a Foundry feature. So this entire IDE is actually using Foundry behind the scenes. If you have no idea what I just said, then please refer to my previous video on what is Foundry and some of the best practices that you will need to know. However, for this tutorial, you will need no experience with Foundry. It just helps to know what's happening behind the scenes. So let's clear this message. And one more thing I want to mention is you'll see this compile tab down here. Now, every time you write code, it will be compiled into bytecode, and any errors that you write at compile time will be caught in here. So if I just type something in like this, the compiler will say, what the hell is this on line 6? Well, really line 5. And that's because this is invalid Solidity code. Basically, this is great for catching errors as you are writing your code. And the validations tab I'll get to in just a moment. Let's start with the first task. So if we scroll down to our left here, you'll see this task down here, which is the actual instructions that you need to follow. Everything else is just information to help you understand the concept. Create two public Boolean variables, A and B. So I will say bool public A and bool public B. The next step says store true in A and false in B. Equals true equals false. Simple. Now, to run this code against the unit tests, you can either click down here or right here, or you press Command Enter if you're on Mac. So Command Enter. Perfect. Now, one more thing I want to show you is in the Details tab, you'll see this ABI validation section here. The ABI is crucial for other entities to interact with your smart contract. So in the Validations tab right here, you'll notice validations are passing. The way it's doing this is it's checking your contract's ABI or application binary interface here, and then it's comparing it to what it's expecting in the backend. Now, you cannot see what they are checking for obvious reasons, otherwise you could just cheat. In this example here, we have a contract that has one Boolean variable, and this is the ABI for the overall contract. It has an input, a name, and some outputs here that are tied to this variable. So the variable is called myVariable, and the type is Boolean. This state mutability is view, and the type is a function because all public variables have an innate getter function. So that's why it says type function here for the variable. And this ABI is what a front end or a back end server would interact with to call your smart contract. So for this tutorial, you do not need to worry too much about that. However, it's good to know that an ABI is essential for applications to interact with your smart contract. So let's move on. Unsigned integers. So an unsigned integer is basically any number in Solidity that cannot go below 0. Now there is a max number, but you do not need to worry about that in this tutorial. Let's scroll down to the task at hand. It says let's create 3 public storage variables in our contract, a, b, and sum. So define a as a uint 8 with initial value between 0 and 255. Let's do that. Uint public, uint 8 public a will be 5. And then another one called uint 16 public of at least 256, which will do 257. And then the other one, sum, should be a summation of those values. So uint 256 public sum should be a plus b. So you can say equals a plus b. Now press Command Enter. There we go. Before we head over to the next stage, click on Details, and it mentions integer overflow and underflow. Now this used to be a very big deal, as it mentions in previous versions of Solidity. You would have to be aware of something called overflow and underflow, which is when your numbers go outside of the minimal and maximum limits for that given data type. So for uint 8, the range here is between 0 and 255. So if your value went below 0 or above 255, you will get an overflow or an underflow, which would then either reset your variable to 0, or it would get set to the maximum number, which is 255 for a uint 8. Now the maximum number for 16 is different compared to 256. If you're curious, I'll whack them up on screen now. Okay, let's head over to the next section. Signed integers are rarely used in Solidity because we don't really want negative values when dealing with money. So it's basically the same thing as a uint in terms of the data type. So you'll have a uint, you'll have an int 8, int 16, int 32, so on and so forth. As you can see here, the range of uint goes from 0 to 255 for uint 8, but for int 8 it goes from minus 128 to 127. They both cover 256 values though, which is the maximum number of values that you can express with 8 bits. The task is to create 3 public storage integers a, b, and difference. Declare the variables a, b as int 8. One of the values must be positive, the other must be negative. Okay, so let's have int 8a equals 5. Oops, let's make it public. And then int 8 public b equals minus 5. Declare the difference as an int 16. So int 16 public difference. And the absolute difference is found by subtracting a from b. So that means a minus b. That would be 5 minus minus 5, which is 5 plus 5. So we should get 10 here. Perfect. So let's head on to the next stage. So far, we've seen Booleans, which is a true or false value. Then we saw uint and int, which is an unsigned, which is a non-negative number, or a allowed to be negative number as an int. Now we're seeing string literals, which is, as we can see here, a defined string. A string in Solidity can be declared as a type byte or a type string. You generally use a string type when you're not sure how long the string's going to be, but if you know the string's going to be tiny, like hello world, then you would use something like bytes. Create a public bytes 32 storage variable. So bytes 32 public message 1, which stores a string literal of hello world. Now you can use single quotes or double quotes, up to you. And the next one is a public string, so string public message 2, which will be a string literal that requires over 32 bytes. To get a string that is over 32 bytes, so scroll up here, and in this example, they actually give you one. So the maximum value, let's say this top value here, copy and paste it in, and this is the maximum value. So if we do one more C, this will now be longer than 32 bytes and it should pass the test. So let's press Command Enter. Oh, we forgot our semicolon. Now let's run the tests. So this string literal here needs to be quite literally hello world. And in fact, we will use double quotes from now on because it does change the it changes the color of the string. So let's just Command Enter this. Next stage. Enums are fantastic for writing cleaner code, especially when you have different variations of something. So in this example, we have a foods enum that can represent apple, pizza, bagel, banana, so on and so forth. And let's head over to the task. If the enum provided, you'll see there are 4 types of foods. Take the values and store them in food 1, 2, 3, and 4. Okay, so simple. The syntax is foods.apple, foods.pizza, and we will say all of them. Now you can put anything in here, to be honest with you. You can even change it. Perfect. Next stage. Thanks for watching. Any questions that you have on basic Solidity data types, please comment below and I'll get back to you as soon as I can. Thank you for watching and I'll see you in the next video.